Hello guys, welcome to the Crack the Placements channel. So today we are going to discuss the Morris preorder traversal. So Morris preorder traversal, the main use case is its time complexity will be O of n and the space complexity will be O of 1. So in the complexity O of 1 itself we can perform the preorder traversal. So this is the importance of Morris preorder traversal. Okay. So let's be clear, in this Morris preorder traversal we will use the concept of the threaded binary tree. So we will use the concept of threaded binary tree. So this is cleared, and always this threaded binary tree will be created on the basis of the Inorder traversal. So how this is linked with Inorder traversal means we are going to create a link between the current element and its Inorder predecessor. So these are the important things which makes the difference between a normal coder and the coder who has understand the traversal techniques and all the things in a very good manner. Okay, now let us consider a tree. Let the tree be 1, 2, 3, 4 and 5. Initially, let us consider a pointer current, and this current is pointing on 1. Okay, so why do we have to create the thread? So I have explained in the Morris Inorder traversal video what is the reason why we are using the Morris traversals. So initially, as you have if you have seen the last video, we were creating the stack like this. That means so we were initially we were present on the 1, and if this one, if the pointer pointing on this 1 is not empty, so we will push this 1 onto the stack, we will print this particular one, and then we will move on to the next that is 2. But in order to avoid this stack, what we will do, we will make use of the links. So in order to create the link, we are going to use the Inorder traversal, that is 4 2 3 1 and 4 2 5 1 and 3. So now the current pointer, that is C, is pointing on 1. So here this 5 is the Inorder predecessor. So we have to create a link from this Inorder predecessor of 1, that is 5, to itself. That is, we have created a link between the 5 and 1. So and after creating the link between this, we will move on to the node C. That is the left child of the node 1, and after moving on to 2, again we have to create a link between its Inorder predecessor, that is 4, and we have created a link between the 4 and 2. So and after doing that, so when we reach 4, so when we reach 4, so we can move on to this 2, and then we can move on to this 5. So in the preorder thing, so what are we going to do? So here, suppose if the current is pointing on 1, we will print that particular one, and after printing that, so we will create a link, and then we will move to the node 2. So then we will print 2. So then we will create a link. So then from 2 we will move on to the left child. So and we will print the value, that is 4. And after moving on to this one, we will check if our currents write. So if this currents write is null or it has a pointer. Suppose if it has a pointer in that particular situation, so what we will do, so we will move on to the so we will move on to the right child of that particular 2. So and after going to 5, we will print the 5 here, and then again the 2 is and again a link is present here. Okay, so from this link we will move on to this one, and after that what we will do, we will traverse to the right child of this one, and then we will print 3. So this is how this Morris preorder traversal works. So, and before moving from 4 to this one, so we have to remove these links also, so that our tree structure will not be spoiled. So now let us understand how the coding is done. So first, so we will create a vector of integers, and it stores a preorder traversal. And after that, let us create a node, that is a pointer, which is which is of type tree node current, and it is currently pointing on the root node. So while this current is not equal to null, I am going to continue this loop. So there will be two cases. The first one, if the current is equivalent to null. So this is one case. If the current is equivalent to null, so this is one case, and the next case will be the current is not equal to null. Sorry, the first case is the currents left is equivalent to null, and the second case is the currents left is not equivalent to null. So let us understand these two cases. Okay, so 1, 2, and 3. So this is the case in which the left child is present. So, and this is the case in which the left child is not present. If the left child is not present, and here the current, so that means the current's left child is not present, in that particular case I am going to print the 1 here, and then I am going to move on to the right node. Okay, so printing means printing, but in this situation we are going to push that element into the vector. So if the currents left is not present, so push the currents value into the preorder vector, and then so move to the right subtree. Okay, so if the currents left is present, so this is the current, and if currents left is present, if currents left is present, so then so we will create a predecessor pointer here, and then we will move on to the rightmost child, and the predecessor will be pointing on this one, and we will look for two cases. If here initially what we can say, the predecessor's right is null. In this situation, let us make the predecessor's right pointing on this particular current. Okay, so then we can move this current from this 1 to here, and after that we will check if this particular so we will check the predecessor in this thing. So here no right child is present, hence 4 itself is the predecessors, and then so we will create the link. Okay, and after creating the link, so what we must do, so we must move on to this 4. So we have traversed this one. So if this currents left is null, so then we will so move on to the right node. So now the current is pointing on this particular node itself, and after that so we'll so we will check so whether our currents left has any kind of so linking or not. If the linking is present, then so what we will do, so we will so erase this particular link, and then we will move on to this particular right child. So this is the way in which the process is going to continue. So first one, we have to find the Inorder predecessor. In order to do that, I am going to create a pointer named predecessor, and let the currents so left is pointing on this one. So while this so predecessor's right is not equal to null, And along with this one, I have already explained that if predecessors right has a link, so here current means it is going to have a link. If it is going to have a link, then what we are going to do, we will remove that link and then we will move to the right child. Okay, so here first we will find the Inorder predecessor. So we have found the Inorder predecessor, and we will check for two cases. If the predecessor's right is null, in this situation what we have to do, in this situation, first thing, if the predecessor's right is null, we have to create a link. Okay baba, let us create a link. Okay, predecessor's right must point on the current, and then after creating that, in the preorder traversal we have to push this particular element into our vector. Okay, and after that, okay, so we will so move on to the left child of the current. Suppose if the predecessor's right is equivalent to current, that means the link is already present. In that particular situation, we have to remove the link. Predecessor's right is equal to null. How to remove the link? Just make it as null, and after that, so move to the current's right. If you do this thing, okay, so your function is cleared, and just return the preorder so vector here. So now let us run the code. Okay, it is saying that okay vector spelling is wrong, so it is VCTOR. Okay, so it's working fine. So let us submit the code. Okay, it's showing 100%. It is the most fastest solution in the lead code. So I have explained about the Morris preorder traversal, so don't forget to subscribe. So thanks a lot.